Right, so today I'm going to show you guys how a starter solenoid works. More specifically, the starter solenoid from a 1947 S11 Desoto. Part number for this solenoid is SS4705, and it's 6V for 6 volt. I don't know what the 8B stands for. But before we dive in, just look at this. This thing is over 70 years old, okay? And just, the car was sitting outside in the rain and the weather for, decades perhaps. God knows how long, but this thing, it's like brand new. I mean, the paint is peeling off, but I mean, just look at the inside. Look, it's like brand new, as if it was made yesterday. Unbelievable. I'll just paint this and we're good to go. And look, it's made of copper here. Look how it's just unbelievable. You see, they made it out of copper so that it wouldn't rust. Just realize, just appreciate how much these guys, the guys that manufactured these cars, how much they had consideration for their clients, in terms of quality, reliability, durability, and ease of repair. Just look at this thing inside. It's brand new, guys. Now go into a junkyard and look at the starters on those cars. They're perhaps 10, maybe 8, 5, 10 years old, and they're hundreds of times worse than this. See, bolts, brass parts, copper bolts, copper parts, it's just unbelievable. Look, everything's like brand new. Anyways, this particular, usually most starters, they have three terminals. Most of them, the vast majority, have 3 terminals. This one happens to have 4 terminals. And the reason for that is, instead, most solenoids, remember what the solenoid does. It pushes the starter motor into the engine, right? Because you don't want that starter inside, turning with the flywheel while you're driving. So this part here, out of this hole here, comes out a plunger, and it pushes it's what pushes the lever and pushes the starter gear inside and mesh with the engine, right? So that's what this does. Now, obviously, this is connected to the ground of the car, right? Which in this case is a positive ground. Most cars, it's negative ground. But the thing is, with most cars, you can start the car without an alternator, right? It'll start. With this car, what they did is they put an extra terminal that's wired through the coils on the generator, which is back there, right? And what that does, if the coil is broken, you can't start the car. So it's just a safety measure to prevent you from, starting the cars if it's going to get stranded, if you're going to get stranded or stuck in the road, right? So it won't start in the first place if you have a bad generator, which is basically the same as the alternator. Just an old version of and simpler version of the alternator, right? So that's what the other terminal is. Instead of getting ground directly to the body of the car, it gets ground. The electricity has to flow through the coil first. It has to flow through the coil to get here. So if there's a problem with the coil, if the coil is broken, then it won't start, right? Now, this terminal here It's where the battery cable went, battery wire. And the other terminal, the big terminal, let's talk about the big terminal, has this part here. The electricity goes through here and into the motor. Right, there's the motor there. There's the lever there. Right. And if you look here, there's a terminal there. And there's a disc. And it's separated. See, the spring holds it there in the middle. Now, when the plunger here is pushed inside, the plunger itself has to go inside because it's an opposite movement. The plunger is pulled inside, which causes the lever on the motor to go that way and push the motor in, right? So, inside there, I don't know if you guys will be able to see, but there is a button. Yeah, you can see it there, you see? See that round part there? There's a button there. Basically a button. And what happens is when you push on it, watch what happens here. Putting my finger in there so that you see. See, it touches this terminal. And the terminal on the other side is the same. You see there? So, this here, it connects these two together, which is basically the battery to the starter motor, right? To the motor. That's what this plunger does. And it's mechanical. There's nothing you can change on it. Now, it's a mechanical switch, okay? See, there's no wires. There's no nothing attached to it. Now, on the terminal here, so now that we got that out of the way, now why do they have to be big and thick? Because the thing that most uses electricity in the car is the starter. Okay, you've got light bulbs, you've got horn, whatever. But the part that most uses electricity, uses a lot of electricity, is the starter. So in order to get a lot of electricity through, you need to have a big, thick wire, and that's the difference between current and voltage. And roughly, so you're thinking, well, 10,000 volts, they're pretty thin wires, right? Because that's voltage. The actual amperage on those wires, it's really, really small. Okay, so here it's the opposite. You need a lot of amperage here. I'm not going to discuss more about that, but that's why you have two really big terminals and then two little ones. Now, how does this work by the key? Now, what you could do is, if we just took everything out and we manually, or by foot actually, push this in, then it would close the contact points and would start the starter, right? So in case of a faulty solenoid, that's what you can do, and it's what I might do. But I don't think this solenoid here is damaged at all. I just think they have the wiring switched up in the manual. So how does this work by ignition switch? That's why, once again, that's why I like the other models, because they had a model that was mechanically activated. You pushed, there was just like a clutch pedal. There was a starter pedal, and you'd push it with your foot, and it would activate this, and that obviously is a lot more reliable. But I mean, this here is pretty indestructible too. It's just a little more complicated. But I mean, it's just as good, but I just prefer, like I said, mechanical is always more durable than electric. Always, 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 right? Because let's say somebody went in here and cut this little wire off, then you're fucked up, right? But how are they gonna cut a pedal, So, but anyways, now let's get into this top part here. As you can see, inside here, there are two wires coming out or coming in, right? But inside this little round black part here is lots and lots of rolls of wire, okay? It's a continuous roll, and it's, as you can see, it's insulated. And what this is, it's called an electromagnet. When you energize this, you see there's two wires, right? When you energize it, and you see that at the top here, there's a space, there's an air gap, and at the side here, there's a set of points. See, and they're normally open. I wonder if I can zoom in. Just give me a second. Yeah. Oh, wow. That's pretty good. You see, they're normally open. Or if you take a good look. Now, why are they open? Because there's a spring here that pushes, that pulls, that's always pulling this end here and keeps those open. This little tab here prevents it from, falling out. So when the solenoid, not the solenoid, the electromagnet is activated, it pushes this down because in the electromagnet it attracts steel, right? So that tab there is made of steel. Let me just see if I can find a. Here, we can use this here. This tab here is made of steel, so it's attracted by the magnet. And when it's attracted, it closes, it connects the points. So all we have to do now is follow where the wires come from and where they go to, and figure this out. So let's start with down here. On the big thick terminal, there's another big thick wire that goes inside. It goes inside here. And in here, there's another electromagnet, right, that sucks the plunger in. I don't have the plunger here, but it's normally held out by a spring, and it sucks that plunger in. So when we close these two contact points here, it not only connects the battery to the starter motor, it seems that it also connects the battery to this wire here that goes inside here. And obviously I won't be able to show you guys what's inside here, but the manual does mention it. And so it connects not only the starter motor, but also the winding here. Okay, so let's see how that works. What's that in the middle? On the other side, apparently there's also a little tab, but it's not connected to anything. There's another little wire there. Coming out from, there's a spring there, you see. Damn, this is it. There we go. Now there's the insulation there. You see, everything's separated. That brown stuff, it's insulation, electrical insulation. It prevents electricity from flowing between these pieces of steel here. So this terminal here, this top right, is completely insulated from the other terminals here. And this bolt here, this screw, is connected to the contact points. So when the contact points close, electricity is able to flow to this bolt here, which is connected to this wire, which in turn goes to the inside as well. It goes to here. Now, is it the same wire as the other one on the other side? As you can see, the wire on this side, it's a lot thicker than the wire on that side. I don't know if you can really see that, right? Now, the wire on these sides, the insulation is sort of worn out, so that could be our problem. Right? So now that we found what's connected to the contact points, let's find what's connected to this terminal here. I don't know, guys, so that's why I actually don't know yet. That's why. Okay, yes. So the two terminals, two small terminals, see, pretty easy. They're connected to the electromagnet. So since both of them are isolated too. Zoom in, motherfucker. Come on. There. See, both these terminals are insulated. So they're not connected to ground, they're not connected to anything. They receive electricity directly from what's coming to the wires to them. And as you can see, they're connected to the terminals here. And this other one, the one on the left side, it's not connected to anything else. So, what happens here? This terminal is supposed to be connected to the generator, which in turn is connected to ground. So this is the ground terminal. It says that in the manual, you can check it. Okay? Zoom in. You fucking bitch. Looks like I gotta press it for it to zoom in, yeah? Okay. So. And, you know, if everything is good, then the voltage here, you know, the ground terminal here, it's constantly on. So this is always, there's always, you know, it's always connected to positive here, which in turn is connected to the electromagnet. Now the electromagnet here in turn has to be connected to the ignition switch. So when you turn on the ignition switch, electricity then flows through here. It's not able to flow through there. You can see through the top here, this metal part, it's not connected to here either. So just to confirm that. And on the top there, it's insulated as well, you see? So it is connected to the spring. What's it connected to? Gotta look for it. Okay, I guess it's connected to ground. Completes the circuit to ground. I understand why they insulated that part though. It's just a holding tab. No, it's actually made of copper. It's not, hang on. That's not insulation, it's just made of copper. So electricity is supposed to flow through here. So it might seem that this is not connected to anything. That top contact point, it's not connected directly to a wire, but it is connected to the metal, to the steel case here, which is connected to the ground, right? So when you turn on the key, electricity doesn't flow through there. It flows through the electromagnet here, providing this has ground from the generator. Right, so let's say that does have ground. Flows through the magnet here, which closes these contact points here. Electricity is then able to flow through here and to through ground. That would create a short circuit. Hang on. Is there a wire that we're missing here? Where the fuck does it connect to? What do those contact points do? Oh, okay, no, yeah. Yeah, this terminal is never connected to this directly, okay? So, turn on the ignition key, electricity flows through here, energizes the electromagnet, which causes the contact points to close. Now, before the contact points close, these two are separated, right? So when the contact points close, it then allows electricity from the ignition switch to go through the contact points and into this winding here, this thin wire here. See that thin wire there, which energizes a coil, an electromagnet inside here. Now the manual says that there are two coils here. One is bigger and stronger, and the other one is smaller and weaker. The big one uses 85 amps, while the smaller one uses 12.5, according to the manual. So, obviously one is a lot bigger, perhaps thicker wire, or just more windings. I'm thinking more windings than the other one. But 85 amps compared to 12.5, that's a huge difference. 85 amps will, if it's used continuously, it will drain a battery in a few minutes, okay, or perhaps even just a few seconds. Okay, so the idea is use that much electricity, but only for a few seconds, perhaps maybe less than a second even, right? Just momentarily. Now the problem that I'm having is on the dash there. The starter turns painfully slow, and as soon as you turn the key to the on position, not cranking the engine, not to the third position, there's a click, which is this click here. Hear that? And the amp meter reads about 18 amps. So what I'm thinking is it's turning that coil on, that electromagnet on, before it's supposed to. Now the idea is the big coil, the 85 amp electromagnet, it pulls. It's supposed to pull the plunger, right? And that thing is pretty heavy. See, if I try to push it by hand, you do need to have a lot of strength here to do that. It is really heavy. If I just use my thumb, I can barely get it to the middle. It's really heavy, so you need a lot of force to pull it in. And the idea is you use that big electromagnet to pull it in, and then you use the small electromagnet to hold it in there. So one is literally called the pull-in coil, and the other one is called the hold-in coil, or just holding coil. Right, so I gotta sort of identify which one. So as soon as you turn on the key, it'll energize this, and this one here with the thinner wire, that should be the pull-in coil, because that's the first thing that happens. This other one here, it's connected. This big thick wire here, it's connected to the terminal. It's not connected to this at all. It's completely independent from this. The only thing that connects this to electricity is when the plunger there connects them to the battery. Okay, so this is mechanically operated indirectly, right? So that implies that this one here, on this terminal here, this is the pull-in coil, right? This is the first one that's supposed to be turned on. And it's thinner wire because it's a lot more windings. This is not that much thinner though. So this wire here is for the holding coil. And the other end of both wires is attached to the ground, which is the case here inside. They're connected there somewhere. So I gotta make sure that that wire there isn't touching the ground. Everything here is, I wonder if that one is. I see the insulation is kind of stripped there, but it is, there's like a brown thicker insulation there, so that brown part at the bottom, that's supposed to be insulation. Now what about the other one? Yeah, I won't zoom in any more than that. Right? That big thick coil, that's the holding coil. So once again, what happens is electricity goes in through here, turn on the ignition switch, energizes this electromagnet, which pulls this down, connecting the points here. Electricity is then able to flow through. Where's the wire that connects these two? Is that little bit of solder there? Yeah, that's connected to the wire. Okay, how does the terminal connect to the unless the point is a ground? Okay, so yeah, as I was saying, yeah, just to make sure. So these two points, these two terminals, They're never connected to the points here. They're not connected at all. They're not connected to anything else either. Electricity flows through here and turns on the electromagnet. That's all that these two terminals do. Now, this part here, there's no wires going to it, but it's connected through here to the case here, which is positive, which is ground. So closing the turning the ignition switch on to the cranking position pushes this down. Oh fuck, that doesn't make any sense because they're already connected there. Yes, but they're not connected to there. Ah, fuck. Yeah, no, that's right. Fuck's sakes. Pardon me, guys. So yeah, electricity flows through here. Yeah, at that point I was just getting confused with that little tab there. It's not connected to the wire here. It's just connected to the this here. It's not connected to the terminal. So all the terminal these two terminals serve for, their only purpose is to turn on this electromagnet. The electromagnet then turns the connects this to ground, which then energizes the pull-in coil, the strong coil, which pulls in the plunger, and the plunger pulls in, and it connects these 2 points, which in turn turn the starter on, but also turn on the hold-in coil. Now, the moment that happens, the engine starts to turn. It says that the voltage here, remember this is connected to the generator. So electricity initially, the generator's off, electricity is flowing from here through the electromagnet, then to here, coming out this way here. Now when the generator's on, the opposite happens. And it disconnects this here, which disconnects these points, which disconnects the hold-in coil. So that's how a starter solenoid works. So normally in most cars, you just the only thing that you're missing is this other terminal here. It's just connected to the it's not insulated. It's just connected to the ground here directly. So you'd only have these three, but the purpose, the idea is the same. Electricity flows through here, through the electromagnet, which connects these 2 points. Electricity then flows